All right, so that was fun. Now we have another experiment that involves a chemical reaction, but with some different ingredients today. All right, so now we're going to start with our materials. Okay, you're going to need some kind of glass jar. Now you don't have to have this exact jar. Even a drinking glass, you definitely want it to be clear, and I think glass is a little bit better to use than plastic. So I'm using my glass jar here. Okay, I need these Alka-Seltzer like fizz tablets. It doesn't matter if you have generic or name brand, doesn't matter. So I have those two. Okay, I also need water, which I already just poured into a measuring cup. It's just straight from the tap. It's not hot, it's not cold. It's pretty room temperature. And some cooking oil. Okay, vegetable oil, canola oil, those all work. Finally, some food coloring. You only need one color for this. My favorite color is purple. Luckily, I have purple, so I'm going to put my purple down there too because that's the color I want to use. All right, so for this experiment, we're going to start with putting oil into this jar. Now we want to fill the jar probably about 2/3. We're going to end up using a lot of oil, so make sure you check with your parents before you use up all their oil. Okay, but this experiment does look a lot nicer and turn out a lot cooler if you do use more oil. So I'm going to pour the oil in. I'm going to use a lot of it. All right, so that's a pretty good amount of oil. It's about 2/3 of the way up the jar there. All right, so start with oil, put that aside now. Next thing I need is to just fill it up the rest of the way with water. Now I want you to see what happens as I pour this water into the jar. Okay, watch what happens. Notice how it's not mixing very well, right? I can definitely see the distinction between the water, which sunk to the bottom, and the oil on top. Okay, why is that happening? Well, that has everything to do with density. Okay, density causes a heavier, a more dense liquid to sink to the bottom. And so oil is lighter than water. Okay, oil is less dense, so it's going to float toward the top. So we have these distinct layers, which often happens when you combine liquids that have different densities. Okay, now the next thing you have to do is just add a few drops of your favorite food coloring. I like purple, like I said. And I would say maybe like, let's see, about 8 drops. And I want you to also observe what happens. It kind of looks a little interesting when you're dropping in the food coloring. You see the drops kind of going all around here. All right. You kind of see that they kind of keep their form. Okay, I'm just going to put a couple more in there. So for a total about 10 drops. All right, whatever color you like to use, whatever you have. All right, so I've got my water, my oil, my food coloring. Kind of looks neat. So on your lab sheet, you might even want to stop and make some observations on what's going on. Scientists always stop and observe what they're doing. So we can also write those down on our lab sheet. Now, no chemical reaction has happened yet. I have to add the Alka-Seltzer tablet. Okay, this happens to have 2 in one pack, but I'm just going to pull one out. Okay, now this is where the chemical reaction is going to take place. Okay, we're making our own lava lamp here with this activity. Okay, so got my tablet here, got my jar, and I'm going to drop this in, and I want you to watch what happens in 3, 2, 1. All right, so that Alka-Seltzer tablet is immediately starting to react. Okay, you see all those bubbles coming up, and now you see that the bubbles are starting to affect the food coloring that was already in there. So now what I have here are all these really awesome purple bubbles swirling around just like a lava lamp. Okay, and it's definitely affected by the different densities of the liquids. Okay, so this Alka-Seltzer tablet combined or reacted with the water at the bottom here to produce carbon dioxide gas, just like in the previous experiment. And that carbon dioxide gas, I can even hear it fizzing, okay, is causing the bubbles to come up around in the lava lamp. And as they move around, they kind of pick up the different colors. And that's why you have that really cool effect. I can still see the density at work here because that water has now been stained purple, and it's not really interacting as much with the oil. So the density definitely affects the movement of the bubbles. Now, you might notice that it kind of stopped now. Okay, it kind of stopped. I could keep the reaction going, or I can make it a new reaction if I add another tablet. If you have more tablets, let's put one in and let's see if we can make that kind of happen again. In the meantime, you definitely in your lab sheet might want to draw a picture of what happened with your lab lamp. Yes, the reaction is continuing now. It's picking up more of those bubbles. That carbon dioxide gas is mixing with the food coloring and creating these really cool bubbles. So in this case, we have a chemical reaction that results in carbon dioxide, but it's a little bit more visually appealing. It looks really cool. It's fun. It's definitely fun to look at. So like I said, you can go ahead and record your results, maybe even think of some other ways that you can modify this experiment. Okay, maybe you can add different colors, maybe 2 different colors at once and see what happens. You could do what I did, and you can keep adding more Alka-Seltzer tablets and see what happens. I definitely noticed since I added the second one, there's a lot more bubbles than there was before. Maybe you can experiment with different water temperatures. The water I put in here was definitely like just, room temperature. You can try it with ice cold water. You could try it with warm water and see if the reaction occurs any differently. So I encourage you to be a good scientist and make those predictions and try different modifications. So that's all I'm going to do with you today. And I'm going to hand it over to Emma, who is going to do your last chemical reaction experiment today. And she's going to make something that you'll actually be able to eat when everything is over. All right, so I'm putting it over to Emma.